to question 2. Oh, so much wording. I don't like this. Okay, sales representatives, men and women. 3. Terms of man. Okay, so this is our probability question. If you didn't figure that out, hopefully you did. So what are the odds that we select 3 women from a group of 6 men and 3 women? Well, first there are 3 out of 9 women. This is the selection of the first woman. Once you select that first woman, there are only 2 out of 8, right? You can't obviously select one woman 3 times to go to the conference. So in other words, obviously 3 women changes to 2 being left over because she's now going, she's out of the list, and now there are not 9 people to choose from, there are 8. So this is choosing your second woman. And last but not least, there's choosing the third woman. There's only 1 left out of the 7 total. This is the odds of selecting 3 women in a group of 3 men, or 3 women and 6 men. So, in other words, that is, well, we can write it like this: 3 divided by 9 times 2 divided by 8 times 1 divided by 7. I think I can write it like that. Let me actually just be sure and use parentheses. 3 over 9 times 2 over 8. Now, obviously you could reduce those, but you don't have to if you're just going to use the calculator. Yeah, okay, so same difference. So you actually don't need parentheses here. That's nice. We just get 0.0119. I usually round to 4 decimal places. Usually on an FRQ, they'll say 3 or 4. Make sure you read that at the beginning. Okay, based on your answer in part A, is there reason to doubt the manager's claim that people were selected at random? I would say yes. I'm going to kind of tie in some alpha speak here. This occurs approximately 1% of the time. I guess, so I'll just say it like this. So it is highly unlikely that this occurred randomly. Okay, so that's my explanation. Yes, and again, because it only occurs approximately 1% of the time. You could also say theoretically 1% of the time, probably. Okay, and now an alternative to calculating the exact probability is to conduct a simulation. A proposed process is described below. Oh, I hate these. Okay, so part C does sound like it makes sense. Let's talk about why. There are 3 out of 9 are women. So in other words, 1/3 are women. So notice what they're doing. They're saying each dice represents a choice, and if it's 1, 2, 3, or 4, in other words, 2/3 of the 6 choices, you would get a man, or if it's 5 or 6, 1/3 you would select a woman. And you do that for each of the dice, and after 1,000 trials, the number of times that the dice indicated selecting 3 women is recorded. Does this proposed process correctly simulate the random selection of 3 women? Explain why or why not. I'm going to say yes. Oh, wait. Sorry, I'm going to say no. Notice what happens here. This is dependent probability. So I said this at the beginning. Oh, it sounded so good, but I caught myself. Notice the probability is changing each time. Your selection of the first woman going now means the odds of the second have totally changed. So the odds of the first, yes, was 1/3, but the odds of the second is 1/4. And obviously the odds of the third are literally 1/7. In other words, the probability changes after the first woman is selected. So it's not always a perfect 1/3 chance of selecting a woman, because again, after the first is selected, the probability changes. So I'm going to say no. In part A, we found the probability correctly because any choice of an individual changes the probability, I'm saying this how you might say it, of the second and likewise the third. Now, how do you say all of that way more quickly? In part A, we found the probability correctly. This means the probabilities are dependent. We actually got a lot of time on this question. Yay. Okay, so the probabilities are dependent. In other words, what happened in the first dictated our new fraction in the second. It wasn't over 9 every time. The probability was shifting every time. So in the suggested, what do they call that, simulation, the dice are independent. In other words, the first dice isn't going to dictate what happens on the second dice. And so it does not accurately simulate the problem at hand. I guess I'll say it like that. It's a weird way of saying it, but hopefully you get what I'm saying. I'm just going to cut that off. But hopefully that makes sense to you. This one, each dice roll has a 1 in 3 chance of selecting a woman. And that was true for the first woman, but notice that doesn't count for the later parts because the probability changes from the first selection to the second because we're not replacing the woman. Once the woman goes on the trip, she doesn't go back on the list to go on the trip again. That would be a waste of company money. So let's see how we did. Okay, perfect. Again, I showed my work. I got my answer. They rounded theirs. So that's fine. So the probability does give reason to doubt because it only happens about 1% of the time. Again, they use 1.2%, so that's okay. The probability is small enough that we could doubt that it was made randomly. So I think I got part B. No, it doesn't correctly simulate the random 319. It's done without replacement. In other words, they're independent. So yeah, my argument is there. And let's see if we can catch that in the wording. Okay, so again, correctly compute the probability and show how it was computed. So always show your work. Don't just slam it into a calculator. You can get a partial. So evidently they wanted you to round to 3 decimal places. All right, and they give you other ways, but who cares? Let's just focus on the right way. Okay, do we state that it is small? Makes a decision with being small and does so in context of the situation. So again, I should have brought more context into the situation. I also could talk about that 1% is very small as well. So I think I'm going to give myself a partial on this. So in other words, see, I didn't use any context, so crap. More context is always better. So see how I looked at it stopped the recording because I forgot about that. But yeah, so in that extra 5 minutes, that's where I'd be looking back, and hopefully I would have told myself, hey, I didn't use any context here. And that's something that I've been saying to myself the whole time. So always go back. Now, I definitely brought in context in part C, so hopefully I got that correct. Let's check. Essentially correct if we respond no, and computes the correct probability and states that the probability is different from the probability in part A. Okay, or, so that was the or, okay. We state the answer is no, and that the dice outcomes in the proposed simulation are independent, and states that the gendered selection convention is dependent. Okay, so I definitely got it from that standpoint. So I talked about the independence and dependence, and this one shows a different probability, so you could actually just show the work like that. Okay, so all in all, I was so close, but I just needed to mention more context in this part of the problem. So always make sure that you're throwing in as much context as possible in any problem that you do. I still technically have 2.5 minutes where I could go back and fill that in. And now that I've finally beat this into my head a million times, hopefully you have too. When you end up having 5 minutes of extra time, you should sit there and go, could I randomly just restate what this question asked? So in other words, yes, this occurs approximately 1% of the time, which is very small, so it's highly unlikely. Instead of saying this, you would say it's highly unlikely that, and what are you going to say? Well, don't feel like you have to make anything crazy up. It's highly unlikely that the three women were selected at random to go on the trip. Done. Now you've integrated context and you get all of your